All right, so I'm going to work on the problem from the Chapter 2 review, problem 30 that we started in class, and just go ahead and finish it up. So I've posted the solutions to this already as a PDF. This is just a supplement, so that if you want to hear an explanation for what was going on, here it is. All right, so I'm going to do this in two parts. I'm going to tackle the first set of questions and then stop the video, start another video, and do a second video, kind of finishing up the problem. It just helps with the data size of the videos, just technical stuff. All right. So problem 30 says this. The Internal Revenue Service, the standard mileage rate, is a way of computing an auto's expense deduction on a tax return. Mileage rates for businesses are provided in table 74 for various years. Let M equal f of t, where f of t is a standard mileage rate in cents per mile at t years since 1990. So we have this function, and the input will be t years since 1990. And the output will be the mileage rate. And that will be in cents per mile. Cents per mile. All right. So that's what function do. Just as a reminder, the input, we call it the domain, and the output, we call it the range. That's the formal names for the input and output. All right, so I'm expecting at this point that you have table 74 in front of you, and let me pull up my calculator. I've already inserted the data. Let me pull it in right here. Okay, I've already put in the data. So 9 for 1999, 11 for 2001, 2003 is 13, etc. So these are the number of years since 1990. And here are all the corresponding mileage rates. So the first question is, find an equation for f of t. Now the way we're going to do that is we're going to take our data and we're going to do a linear regression. Okay, now from the context of this chapter, since we're in chapter 2 was about linear regression, it probably is worth at least looking at the data real quick. So I'm going to go to second y equals, go into stat plot 1, make sure it's on. Okay, make sure that the scatter plot selected. I'm looking at list 1, list 2. That's where I put my data. And then I'm going to zoom 9, which is zoom stat, and push enter. And it seems that by and large the data fall into a straight line. There's a little bit of a dip here, but that's okay. It looks like by far and away it falls in a straight line. So I think a linear model will do it. Okay, so to calculate this linear equation, I go to stat, I go to calc. I'm going to go down to number 4 for linear regression. It says list 1, list 2, that's what I wanted, and then I'm going to store my equation in my y equals. So I say vars, y vars, function, y1, and calculate. All right, so what I have here is y equals ax plus b. So a is the slope of my line and b is the y-intercept. So let me see. So 2.17, we'll round it up. So I say f of t is equal to 2.17 t plus, and I'll get my y-intercept, 10.28. 10.28 I think will be fine. So keep my decimals rounded to the same place. Okay, so in answer to the first part, find the equation for f of t, that would be it. So again, input t years since 1990, and then it will output the mileage rate for that given year, the estimated mileage rate. So let me copy this. We're going to use it in the next slide. Come on now. Copy. Okay, what is the slop? Oh, I should probably say slope. What is the slope? The question says, and what does it mean in this situation? Okay, so the slope of the line is this value right here. So if you remember the slope, is the what we say the rise over the run. That's kind of the most generic way we say it. Basically, it's the change in the response variable over the change in the explanatory variable. Okay, now if you look at the table, the response variable is the mileage rate. And the explanatory variable is time, years since 1990, time since 1990. All right. So then, our number, we have this ratio then, 2.17. And what it's saying is it's 2.17 cents per mile, okay, over the year, for every 1 year. All right, so what this is saying, I'll just type out the answer now, is that for every 1 year of change, so for example, you think of going from 1990 to 1991, so every year of change, the rate increases by 2.17 cents per mile. Okay, so remember, the slope is the rate of change, how much cents per mile is changing every single year. Okay, so then the next question, so that's B. So what is the m-intercept and what does it mean in this situation? All right, so m-intercept, interesting. So remember, if we're looking at a graph right here, time is the explanatory variable and the response variable, they've called it m. They define that in the question. And so we're looking, we're looking at roughly this value right here. So the m-intercept is 0, comma, some number. Now the equation should tell us what that number is. So let me grab it. Here we go. All right, so in this case, the m-intercept is this value, 10.28. So at 0, the value is 10.28. So what does 0 represent to us? Well, that is 0 years since 1990. 0 years since 1990. So in other words, this represents the year 1990 itself. And then the 10.28, well, that's the rate at year 0. So what the y-intercept is telling us, and this is an estimate, that we estimate, if this trend has been holding the whole time, that in 1990, the rate was 10.28 cents per mile. Okay, now it's kind of important that you recognize that time 0 represents the year 1990 because it gives you very specific information. So don't say at time 0 the rate was 10 cents, 10.28 cents. Say in the year 1990 because that's actually what time 0 means in this context. Okay, so I'm going to stop right there. Go ahead and look at the next video and I'll answer the next 2 sections of this problem.